right, if you did the extra credit, go and have it out. If you didn't do the extra credit, get out some graph paper and let's work this function together. We talked yesterday about graphing secant and cosecant, and for both secant and cosecant, my suggestion was to start with the graphs of their reciprocals. So for cosecant class, we would want to start with the graph of sine, right? So the graph of sine, remember, your key points are, class, 0, 1, 0, -1, 0, right? Pi over 2, pi, 3 pi over 2, 2 pi. So the graph of the sine curve, something like that, right? But for the cosecant, we said we're going to take the reciprocal. And what do you get when you take the reciprocal of 0, class?
0.
No. Undefined. An asymptote is how we're going to graph it. So that the f of x axis would become an asymptote then, right? And then the next pi would become the asymptote. At 2 pi, that would become an asymptote. Remember, we said that for cosecant, the domain is all real numbers except at n pi over 2 when n is an even integer. And then, of course, we said when we take the reciprocal of a 1, we get, and the reciprocal of -1, -1. And then we have like a 1/2 here and here, a -1/2 here and here. And when you take the reciprocals of a half or -1/2, you get 2 or -2 when you flip it, right? 1/2 when you flip it gives 2. So we should have a 2 and a 2 and a -2 and a -2. And so we end up with this U-shaped curve approaching the asymptote, and then a U-shaped or an N-shaped curve approaching the asymptote. Again, just kind of a sketch thrown up here. And that's your basic cosecant curve. So that can help you remember your key points for the cosecant class are asymptote 1,
asymptote 1, asymptote.
Well, -1, and then the asymptote, right? But we're going to change some things up here. First of all, I see the 2 right here. What does the 2 change for us, Chris?
Multiply everything by 2.
And we're multiplying everything by 2. Well, you can't really double an asymptote, but you can double a 1 to make it a 2, and a -1 to get a -2. And then what does the denominator 3 here change for us?
The horizontal shift?
No, the period, right? And we said for secant and cosecant, the period is normally
Pi.
That's for tangent and cotangent.
2 pi.
2 pi, just like sine and cosine, they're reciprocals. But technically it's going to be 2 pi over b. Well, if b is represented here, then the b value is actually a
2 pi over 3.
Well, not 2 pi over 3. What is multiplied by the x here? Not a 3 class, but a 1/3, right? This could also be written 2 times the cosecant of 1/3 x. So the b here is actually a 1/3, meaning the period of this graph is going to be 6 pi. So, when we go to graph this,
I didn't do it right.
we're going to, that's why it was extra credit. And I don't have my graph paper grid up here, but we're going to have fun with this anyway.
6 pi.
All right, so
I don't know the formula.
so every 3 boxes, right, is pi over 2.
I could have done that.
And then 3 more boxes, pi. 3 more boxes, 3 pi over 2. 3 more boxes, 2 pi. 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. I feel like I'm getting a little bit shorter though. 9 pi over 2. 10 pi. 11 pi over 2. Not 10 pi, 5 pi. 10 pi over 2. And then not 12 pi over 2, 6 pi. All right, so that's where the graph has to start and end. In addition, I'm going to stretch it a little bit, right? So 1, 2, 3, 4, f of x.
I think you'd have to literally turn the paper sideways to do this.
Probably. And this is why we're doing the extra credit on video. And so we're going to start at an asymptote, and we're going to end at an asymptote that I accidentally erased. And halfway in between at 3 pi is another asymptote, right? And then 2 is going to be halfway between, so that's going to be at 3/2 of a pi. It's going to be up at 2. And then halfway between here, we're going to be at -2, which would be at 9 pi over 2. So about -2 looks to be right about there. And remember, we said normally it's the box next to the asymptote that is your 2 or your -2. But we're doubling those to 4 and -4 there. And that's going to be not one box, but 3 boxes because everything's been stretched out 3. So that's going to be here at pi over 2. We're going to be up at 4. And 5 pi over 2, we're going to be up at 4. And then here at 7 pi over 2, down at -4. And 11 pi over 2, -4. So we're going to get a very gradual curve here and here and here and here. And so that's what it would look like, really stretched out this way and a little bit stretched out that way as well. And that's what we would have had for the extra credit. Questions on this?
Have you ever given this extra credit before?
Yeah.
Has anyone every year?
I don't remember. Yes, ma'am. So if this were the sine curve, right, it would have been 0, 1, 0, -1, 0. So here's what the sine curve would have looked like with that same period, right? But instead of the 1s, it's doubled to a 2. Instead of 1/2, it's doubled, it's flipped to 2, and then doubled up to the 4. Does that make sense?
Right. Okay, I think I see.
All right, good. All right, any other questions? Again, it helps to see the sine curve when you're dealing with cosecant. It helps to put things in perspective. Questions on this?
That's kind of evil, isn't it? Like to give this? Is that correct?
It doesn't hurt to give it. I mean, half of you didn't do it anyway.
It really wouldn't have been on the paper.
Turn sideways. Come on, now don't be lazy bums, all of you. All right, let's take a look at your ACT. Let's take a look at your ACT practice test. Go ahead and set that aside. And again, we'll go over as much of this as we can this hour. We'll finish it up in the next lesson on Monday for you guys, whatever day for those watching.
Where's you, Chris? Yes, I got my name wrong. No. He said first name. He says it.
Be quiet. All right. So since Chris doesn't have his, what I would suggest is go on YouTube, print it out. It's in lesson, let's see, this is 47, probably lesson 44. You'll see the link to the document. Print it out, work on it, then you go back and rewatch this after you've redone it. You'll have an advantage of having seen it once already, but you know, whatever. All right, let's take a look at the test together. First page, which is actually page 22. This is actually looking like what the ACT will look like. Okay, so we hit section 2. Every section has a different symbol at the top. So you see triangles. The reading section might have squares. The English section might have circles, right? Just depends. The shape of the top has nothing really to do with the test. It's just so when you see those, you know you're still on the same test. So if you were to get to squares at the top, you're like, oh, I should be done by now. Also, you would run out of room on your Scantron document. You see all the initial directions and stuff, because it is a Scantron test. You'll be filling in ovals. And then there's some little assumptions that we take, right? Illustrated figures are not drawn to scale necessarily. Oftentimes they're pretty close, though, but you can't assume drawn to scale. Geometric figures lie in a plane, hence plane geometry like we studied last year. Line means straight line. Okay, if we meant curve, we'd say curve. And average means the mean, okay, which, that mean means average, average mean. Okay. You are permitted to use a calculator or anything. Notice it does say some of the problems may be best done without using a calculator, so don't be married to the calculator. Let's take a look at these together. No questions, you don't even have your test. All right, number 1. Numbers 1 through 15 written on individual pieces of paper. 1 number per piece, 15 pieces of paper put in the jar, 1 piece drawn at random. So the probability of any one piece is 1 to 15. But what's the probability of drawing a piece of paper with a number less than 9 written on it? Well, how many pieces of paper have a number less than 9? 8 of them, right? 1 through 8 are all less than 9. So there's 8 chances in the bag out of 15 total. So what's the probability? 8 to 15. You learned that in junior high. We also looked at that in 10th grade. Number 2. Which of those expressions is equivalent to -4x cubed, -12x cubed, positive 9x squared? Well, all we got to do is combine like terms to get
-8x cubed plus
-4, -12, -16x cubed plus 9x squared, letter J. But all you do is combining like terms. That goes back to Algebra 1, maybe even pre-algebra. Number 3, if x is 2, then what is 10 plus 3 times the quantity, 12 divided by 3x, equal? Class? B, 16. Follow order of operations. First of all, simplify the 3x to get 6. Divide 12 by 6 to get 2. Multiply 3 times 2 to get 6. Add 10 plus 6 to get 16. Number 4. The absolute value of 6 minus 4 minus the absolute value of 3 minus 8 gives what? G, negative 3. G, negative 3. Absolute value is 2. Absolute value is 5. 2 minus 5 equals negative 3. Again, that goes back to pre-algebra and algebra 1. Number 5. That expression is equivalent to what? Well, we see two similar binomials. How do we multiply two similar binomials? So all you got to do is FOIL those things to get letter C for your answer. First, outer, inner, last. Should have given you a 12c squared. Your outer is a positive 4 CD. The inner is a negative 9 CD, which gives us the negative 5 CD. That narrows it down to C or D. And then when you multiply the last, that's a negative 3D squared because the signs are different, hence we choose letter C. Number 6, of 180 students in a college course, a fourth of them earned an A, a third of them earned a B, everybody else earned a C. Apparently nobody failed. How many students earned a C for the course?
F, 75.
Should be letter F, 75. A couple ways you could do this, but I think the easiest is, well, what is a fourth of 180?
45.
45. What's a sixth of 180?
60.
60. So that's 105 kids already spoken for, right? How many kids are left? 75 of them. The more involved way is 1/4 and then a plus a third gives you, what is that, 7/12? So there are 5/12 of the students left, and you can take 5/12 of 180. Why? Why would you do it that way? Okay, do it the other way I just said a minute ago. All right, number 7. The number of fish, F, in Skipper's Pond at the beginning of each year can be modeled by the equation f of x equals 3 times 2 to the, is that an x?
Yeah.
Okay, I scribbled on top of some stuff here when I was working these. Where x represents the number of years after the beginning of the year 2000. For example, x would be 0 for the year 2000, x would be 1 for the beginning of 2001, and so forth. So according to this model, how many fish were in Skipper's Pond at the beginning of the year 2006? Well, what should x be, class? 6. So we've got 3 times 2 to the 6th. Well, you just plug that in, and what do you get? Letter B, 192 fish in the pond. So apparently, Skipper's Pond in the year 2000 would have had 3 fish in it. They're like, well, if we just don't fish it at all, we just let the 3 fish repopulate themselves, then eventually we'll have more fish. And yes, stocked ponds are where it's at for fishing, especially if you get there at the normal feeding time. Anyway, some people call it cheating. I call it strategic and lazy, because who wants to sit out there for 2 hours without a bite? All right, anyway, questions on the first page. Feel like first page pretty straightforward. All right, let's go to the second page.
It gets harder.
It does get harder as you go through the test. It's true. They tend to put easier problems at the beginning, harder problems at the end. But you can appreciate that, right? You don't want the hard problems at the beginning and you get stuck and never get to the easy stuff, right? Number 8. Manish, I guess is his name? Manish. I guess it's a mannish thing to do, manly, mannish. Anyway, Manish drove from Chicago to Baton Rouge. At 8 o'clock, he was 510 kilometers from Baton Rouge. At 1 o'clock, he was 105 kilometers from Baton Rouge. Which of the following values is closest to Manish's average speed in kilometers per hour from 8 to 1? Well, how do we find average speed or average velocity?
The equation.
Displacement per unit time, right? So we know the time from 8 o'clock to 1 o'clock is 5 hours, right? And the displacement, well, he was 510 kilometers away, and then the next time we checked, he's only 105 kilometers away. How far did he actually travel?
405.
405 kilometers. So we take that displacement traveled, or distance traveled, divided by time to get h, 81 kilometers per hour. H, 81 kilometers per hour. If that were miles per hour, he would be speeding. In kilometers per hour, he's not speeding.
That's speed. And that's all kilometers.
Yeah, I know. All right, number 9. In the figure shown below, E and G lie on AC. Yeah, that's pretty obvious. D and F lie on AB. Also pretty obvious. D, E, and F, G are parallel. I would have guessed that. The given lengths are in feet. Who cares? None of the answers have feet in them. What is the length of AC in feet? Do you see how a lot of the information really doesn't matter? Now, remember with the SAT, you had to read real careful because they try to trick you. ACT, not really trying to trick nobody here. What you see is what you got, right? So we look at the numbers that they give you, right? And what do you notice about these transversal pieces being cut off by the series of parallels? Well, there are two pieces that are in relation to each other, AD and AE, right? One's 8, one's 16. What's the relationship? They double. So what's EG? 14. So what's GC? 12. All right, so I just filled those in real quick before I even read the problem. And then it said, what's the length of AC in feet? Because I'm like, well, what are they asking for? Well, to find AC, what do you got to do?
Add them all.
Because the whole equals the sum of all its parts. I mean, this is pure geometry in there. And we get
42.
42, letter D. The letter D. Number 10. Katerina runs 15. By the way, she did not leave that love note for me, apparently.
You did.
No, she left it, but it was supposed to, like, she's like, I don't know, I think it was like Lydia or Ashley or somebody. Anyway, I have no clue how it ended up in my stack of papers, but she did confirm it was her. She was like, wow, that's really old. That's, almost 3 years old over there.
I'm gonna text her.
Anyway, yeah, I messaged her on Facebook, took a picture. I was like, hey, I found this after 2.5 years. Wow, that's really weird. So anyway, she's taking exams today. I'm praying for her. All right, they're behind you guys. You're already done with exams. Katerina runs 15 miles in 2.5 hours. That's a lie. Katerina does not run at all.
Yeah.
All right, what is it? Now I'm picking on Katerina. She's not even in this house. I'll have to send her a link to this video. Tell her, hey, we thought of you. So in the problem on the ACT practice test, Katerina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? Here you kind of use a proportional idea, though you may not actually write it as a proportion. 15 miles in 2.5 hours. But notice it changes over to minutes, right? So how many minutes are in 2.5 hours? 150, right? 60, 60, and 30 gives you 150 minutes. So basically 15 miles, 150 minutes. How many minutes for each of those miles? 10. So how many minutes would it take her to run a mile? G, 10. All right, you could kind of use the proportional idea, or you just kind of think it through logically, and you get that 10 minutes.
I was like, it took me that.
Number 11. Here's a fun one. Bag contains 8 red marbles, 9 yellow marbles, 7 green marbles. How many additional red marbles must be added to the 24 marbles already in the bag, so the probability of randomly drawing a red marble would be 3 to 5? So here's what I got. There's 24 marbles already, right? And of the 24 marbles, we have 8 red ones, correct? So right now, what's the probability of a red marble? 1 to 3. We want to bump it up to a 3 to 5. So I'm like, well, 3 to 5. That could be 15 to 25, but adding 1 red marble gets you to 9 to 25. That's a far cry. So I'm like, well, if I did, 30 to 50, well, that would be adding 26 more marbles. But if all of them were red, that's too many red marbles. So let's come somewhere in between there. Instead of multiplying by 5 or multiplying by 10, let's multiply by, 7. 21 to 35. That's 11 more marbles, but that's not 11 more marbles. That would be 13. So how about times 6? Well, that would be 18 to 30. And that would mean adding 6 more marbles. That's not working for me. Let's see, times 8 would be 24 to 40. Let's see, actually, no, that would be adding, where did I get the 16 a minute ago? 35, yeah. So if going back to this one, sorry, this was the times 7 one. This would be adding 11 marbles here, but if all 11 marbles were red, I'm not up to the 21 I need. So yeah, so times 7 wasn't enough. I don't know why I did times 6. Times 8, 24 to 40. Well, that would take 16 more marbles, and if all 16 of them are red, there it is. I need 16 more marbles. Is there an easier way to do it? Maybe. I don't know what it is. That's what I did. Though somehow I got to it on my second try. I got the 15 to 25, and I got to the 24 to 40. Not sure what I did there exactly, how I got it quicker the other time. But anyway, we need to make an equivalent ratio is what it boils down to. Which of these numbers, if we added it to top and bottom, would give us the equivalent ratio? I guess you can just take them in order. Try adding 11 to both. 19 to 35, that doesn't equal. Add 16 to both, 24 to 40. Oh, that equals. Maybe that's what I did. Questions? Oh, number 11. How many got letter B? 16 marbles added? And they're all red. Okay, so y'all figured it out as well. Good. I'm sure there's a faster way. But I got 2 hours of sleep last night. And I did this 2 weeks ago.
2 hours?
So I had a sick kid, and she kept waking me up. And anyway. Number 12.
I wouldn't live right No.
I'm just barely. Yeah, you wait till I have to umpire that kickball game
Oh my
today.
goodness.
Yeah, everybody's out. Everybody's out. I'm getting home. No, even you guys. You're tossed out of there.
Arguing with the regular.
There you go. All right, number 12. In the standard XY coordinate plane, point 2, 1 is the midpoint. C is the coordinate 6, 8. 2, 1, that's the midpoint. 6, 8. All right, so somewhere around like here-ish. So I'm expecting something third quadrant. That's just my guess. So 2, 1, 6, 8. To go from the 2 to the 6, what do I do, class?
I'm studying.
No, well, mathematically, I guess, but from 2 to 6, what am I doing? I'm moving forward 4 along the x, right? So if I'm going forward 4 on the x, I'm going to have to go backward 4 to get to -2. To go from 1 to 8, I'm going up 7. So I'm going to have to go down 7 to get -6. There's my other point, -2, -6. How many letter G for your answer? Okay, do you see how going one direction and just go the other direction is going to get it for you?
So it wasn't in the third quadrant, and then.
-2, -6 is in the third quadrant.
Oh yeah.
But I didn't actually draw a graph when I did it the other time. I just went, well, add 4, add 7, -4, -7, -2, -6. I didn't actually use the picture when I did it the other day. But on 2 hours of sleep, pictures are helpful. All right, number 13. Why are we even recording right now? I don't know, because I don't want to record it later. Number 13, lazy, remember? All right, at his job, first 40 hours of each week, Thomas works his regular time. Any additional time that he works is overtime. We talked about this in junior high math, right? Thomas gets paid $15 an hour during regular time. During overtime, he gets 1.5 times as much. How many remember talking about time and a half? Junior high. As he gets paid during regular time. He works 46 hours in 1 week and gets 117 in deductions taken out of his pay for this week. After the deductions are taken out, how much of Thomas's pay for this week remains? This is like a gazillion steps. Okay, so $15 an hour, but only for how many hours? 40. All right, so how much money is that? Calculators. Calculator.
600.
600, there we go. Okay, you're going to need it in a second, though. We didn't need it for that, but we're going to need it in a second. He gets 1.5 times this for overtime hours. So what's his hourly rate for overtime? 22.50, right? But how many overtime hours did he work? 6 of them, right? So multiply 6 times the 22.50. How much more money?
135.
135. So how much total money did he make?
735.
735. That's before Uncle Sam comes in and says, whoop, I'm going to take 117 of that. How much does he get left with, class? 618. Letter D is our answer. How many have that answer? Good question on that.
Uncle Sam.
Yeah, good old Uncle Sam. Yeah.
We all have that uncle that takes turns.
We do. Some people have more than one uncle. We all have Sam. All right, number 14. And it's just getting worse, people. It's just getting worse. And inflation on top of that. All right. Gas over $3 a gallon. Here. This is one of the cheapest places in the country. Yeah.
That's California.
I know, for real.
$8 a gallon.
All right. Number 14. As sweet stuff, fresh produce. Okay, there's a restaurant in town called the Juicy Seafood. Any of you eaten there yet?
I have not yet.
Okay, my wife just can't do the name. She's like, no,
Juicy.
it's just juicy. Like an apple should be juicy, cherries should be juicy, seafood should not be juicy, she says. I'm like, I don't know, like, you bite into shrimp, there's a bit of a juicy texture to shrimp, that's good, I love shrimp. But she's like, no, so we are not eating there. Anyway, sweet stuff, fresh produce. Price of a bag of grapes depends on the total number of bags purchased at once. All right. By the way, this happens online a lot when you buy quantities. I don't know if you've seen it, but you buy this quantity of stuff, you get this price. You buy a bigger quantity, lower price, bigger quantity, lower price. So anyway, that's how they do bags of grapes. So in 2 trips to Sweet Stuff, Janelle purchased 3 bags of grapes on Monday. And then 2 days later, she's buying 4 more bags of grapes. Maybe she works at a daycare or something. Otherwise, I have no clue why anyone needs that many bags of grapes. she just really loves grapes, or she's making wine, which, anyway, she's juicing. All right, so how much money would Janelle have saved if she instead purchases the 7 bags all at once? Okay, so trip number 1, she buys 3 bags. How much per bag?
$3.
$3. How much money is that?
$9.
$9. Next trip, she buys 4 bags. How much money is that per bag?
$2.80.
280 times 4 gives you
$11.20.
$11.20. So how much is she spending at the store? $20.20. That was not a good year for anybody. All right. And that's in hindsight, by the way.
That number is burning my eyes.
Yeah, okay. But what if she just went on Monday and bought all 7 bags of grapes? Well, for one thing, some of them probably would have gone bad before Wednesday, so that's why you don't buy them all at once. But if she just buys all 7 bags at once, how much is she paying per bag? $2.60 times 7. $18.20. So she could have paid $18.20 instead of $20.20. How much would she have saved? $2. Letter J. How many had letter J for number 14? All right, questions. Number 15. What is 3% of 4.14 times 10 to the 4th? You can literally plug this into your calculator. I didn't because I didn't want to pull my calculator out because I was lazy. But you could just plug in 3 second function percent times 4.14 equals, and it'll spit out the answer of
A.
Oh yeah, letter A, 1,000. I'm sorry. For some weird reason, I'm looking at the number. Normally, I'm looking at the letter, and for some reason, I was waiting for 1,242. Like A, yeah, letter A, duh, 1,242. The way I did it, I knew there were going to be 4 decimal places moved. So without the calculator, 2 of those are the 1 and the 4, and then 2 more zeros, and times 0.03. Knock off 2 zeros, knock off 2 decimal places, multiply by 3, get 1,242. But I don't know. Maybe the calculator is quicker.
Mine is.
On a day like this, it's probably quicker. All right, we go on letter A. All good there, letter A. Good. All right, number 16. Basic equation, like you would have solved in Algebra 1.
I don't remember Algebra 1.
Let me help you remember Algebra 1. Because in Algebra 1, you had this poster. You remember this poster? Back in the good old days when math was fun and easy. Yeah, so I'll put it back up because we're still solving equations in Algebra 2 and now we're using the poster for that. But get rid of parentheses, right? So we have to distribute first. And negative 12x plus 15 equals 2 negative 10x. Then we combine on each side, except you can't. So then you get rid of the little x, and the little x is the negative 12x. So you move it over as a positive 12x to get 2x. You move the 15 over as a negative 15 to get, 2 over as a negative 2 to get 13. You divide both sides by 2, you get 13 2ths. How many got? Letter K, 13 halves.
It was pretty easy.
All right, Quentin, let's go through this one more time.
No, I get it.
You got it now?
I didn't think about it like that.
Oh, you tried to actually plug in numbers?
Yeah.
Don't plug in numbers.
Please
It's
don't.
literally quicker to just solve it than it is to plug in all those numbers. All right, but this is why we do the practice test, right? Because sometimes our brains overcomplicate things. And so if we have a chance to see how easy it is in class, then when we take the test in another week, we're like, I got this. I'm not going to do this the hard way. Number 17. Hey, this is very now, right? We got our triangle ABC. And they marked angle. No, they didn't. That was my marking. I marked angle A. And they said, what's the sign of A? And sine is always what over what class?
Opposite over hypotenuse.
Opposite over hypotenuse. What's the opposite?
D.
7. What's the hypotenuse?
9.
9. So what's the answer?
D.
7 to 9. Couldn't be easier, right?
So easy.
Number 18. This takes me back to Algebra 1 and Algebra 2. And you could do this on your calculator. You plug in 27 fractions 64, y to the x, and then you do 2 fraction 3, hit the negative sign, and it equals, and you get J for your answer. Now, if you were doing it the way we did in Algebra 1, where you couldn't use a calculator, you'd remember that a negative exponent means reciprocal. So you change it to a 64 27ths. And you remember the 2/3 power, this is the root, this is the exponent. You'd start by taking the cube root of 64 and the cube root of 27, and then you'd square to get 16 ninths. And that's how we did it in Algebra 1. You got a calculator now, and it does it all for you. 16 ninths, letter J. Number 19. I said they're straightforward. They tricked me. I got this one wrong. Yep, I did, and I was bitter.
Which one did you get wrong?
Number 19. All right,
No,
so
which one?
well, you're about to find out. Lodo begins at his That's a great name.
Lodo.
Sounds like a name from Star Wars, doesn't it?
Monkey.
Lodo begins at his back door and walks 8 yards east. Sounds like a physics problem now. 6 yards north.
I tried drawing this.
Then he walks 12 yards east. Then he walks 5 yards north
Who does this?
to the barn door. Lodo, obviously. All right. It says, about how many yards less? I did not see that word because I was reading too fast. About how many, as soon as I read all those numbers, I was already solving it. How many yards less would he walk if he just walked directly from the back door to the front door? Now, is this all entirely a straight line? No, it's 2 hypotenae, correct? They're not, it's not one continuous straight line, but it's really close, okay? You recognize the 3, 4, 5 right triangle here? 3 doubled, 4 doubled, 5 doubled. What's the hypotenuse? 10. And here is a 5, 12, 13 right triangle. You could use your Pythagorean theorem and your calculator to get that. So how many yards would Lodo walk if he just went straight? About 23. Again, it's not necessarily collinear, so it's not exactly 23, but it's really daggone close, okay? Now, how many yards did he walk? 8, 6, 12, and 5 adds up to
31.
He did walk 31. I put 23 as my answer because I'm like, that's how far he should have walked. But it didn't say how far should he have walked. It says how much less. And I never subtracted to get 8. Letter A. Jerks. All right, number 19 should have been A. If you put C, then that means you did what I did, and you found how far he walked, which is the main part of the problem. You just didn't read the word less.
I just did what we do in physics. You draw your arrow up north and then east and then.
Yeah, that's what I did too. You could have also gone 20 and 11, and it would have given you an answer of about 23 also. But again, that's not what they were asking for. They were asking how many yards less. Anyway, I'm slightly bitter. Questions on 19.
Slightly bitter.
I know. I hate it. I hate being tricked. I don't like being tricked. And I'm like, ACT, we're straightforward, right?
No.
Jerks. All right, number 20. So apparently you're not safe with the ACT. Number 20. For a given set of data, the standard score Z corresponding to the raw score X is given by Z. This is the only part that matters. Z equals X minus mu over sigma.
Yeah.
Where mu is the mean of the set, sigma is the standard deviation. By the way, do those numbers, like you're like, hey, I remember learning things like standard deviation and mean in algebra 2. While we were doing the, well, you weren't in the Zoom as well. Y'all were doing the Zoom. We didn't get that far. Anyway, if for a set of scores, mu is 78, sigma 6, which of the following is the raw score X corresponding to Z equals 2? All right. Literally, all you gotta do is plug stuff in, folks. You don't have to understand any of that. It says Z is 2, so you put a 2 where the Z was. It says mu is 78, so you put a 78 where the mu was. It says sigma 6, you put a 6 where the sigma is. And it says, what's the score X? You leave the X there because you ain't know it yet. Does that make sense? Don't get thrown off and confused by problems. I get students come back from the ACT all the time. It was so hard, Mr. Dasky. That's because you have problems like this that are stupid easy. All right, question. What divided by 6 equals 2? 12. This thing has to equal 12. How would I figure out what X is?
Just add 12.
Add 78 and 12 to get what?
90.
You know X has to be 90. Don't make it hard. Letter F.
Yeah.
How many got letter F for number 20?
I mixed that up with H for some reason.
All right, questions.
I meant F.
All right, let's take a look at number 21. Hey, this looks like geometry again. A, B, C, D, line of a circle centered at O. Which of the following does not appear in the figure? An acute triangle, equilateral triangle, isosceles triangle, right triangle, or scalene triangle? Do we have an acute triangle class?
Yes.
Yes, AOB. Do we have an equilateral triangle class?
Yes.
AOB. Do we have an isosceles triangle class?
Yes.
AOB and COD. Do we have a right triangle?
Yes.
COD. Do we have a scalene triangle?
No.
Evidently not, because everything has 2 radii in it. So, E. How many put E? Good. Oh.
I
What?
didn't guess myself. I had E and then I changed it to A.
Shine, shine, shine. All right, number 22. What's the slope of a line in the standard xy coordinate plane parallel to x plus 5y equals 9? What's slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. Where slope is what of what?
Right, so remember.
What would make lines parallel? If they have
Same,
same slope, right? So for this line, x plus 5y equals 9. If I can get y by itself and get the equation in this format, I'll see what the slope of this line is. So I'm going to bring the x over, remember, as a negative to get 5y equals negative x plus 9. I'm going to divide 5 from everything, and I should see the slope of my line given to me as negative a fifth. Well, that means a parallel line is going to have what slope? Negative a fifth. And there's our answer, letter G. Letter G. Get it in slope-intercept form. Y'all remember doing that now? Algebra 1, Algebra 2? Questions? Number 23. Given that y equals x over x minus 1 and y is greater than 1, that's important only because, or x is greater than 1, excuse me, that's important because if x is smaller than 1, you could get a negative for y. If x is equal to 1, you could get an undefined value, right? So that means you're guaranteed your denominator is going to be positive, and you're guaranteed your numerator is going to be positive. And you're guaranteed, class, that your numerator is going to be bigger than your denominator. Did you catch all of that? Numerator has to be positive because it's greater than 1. Denominator is going to end up being positive also. Positive divided by positive equals positive. You can rule out A and B right there. Also, the numerator has to be bigger than the denominator, not equal to. So we know we're going to get a number that's bigger than 1. So the only possible answer is E. Letter E. Does it make sense, the logic behind it now? That's almost an SAT style question because it's never taught in those terms, but you're thinking through all the facts that you know. Questions? Page 25. Question 24. The set of all positive integers that are divisible by both 15 and 35 is infinite. In other words, there's an infinite number of numbers divisible by 15 and 35. But what's the smallest positive integer? Okay, we call that the LCM, the least common multiple. You remember learning about least common multiple when you were in junior high? So you're trying to find the smallest number that has a 15 in it and a 35 in it. What's the smallest number like that? 105. Can't be 5. 5 doesn't have a 15 or a 35 in it. Can't be 50. 50 doesn't have a 15 or 35 in it. 105? Yeah, that's divisible by both. There's your answer. Or the junior high way is to factor and take all your winners. Now here it's a tie. Remember you were told just pick one to be the winner and one to be the loser. Kind of like what the referees do in kickball. One team's going to win, one team's going to lose. It's just whatever we pick. So one team, everybody's out. The other team, everybody's safe. Just kidding. That's not what we do.
Sorry.
We don't pick winners. All right. Picking on Ethan now. Ethan helps coach the Sharks, in case you're wondering. He takes all the credit for their success.
Yeah, exactly.
All right. All right, number 25. Triangle ABC shown below. Measure of angle A is 58. AB and AC are equal. So what kind of triangle we got, class? Isosceles, right? Which two angles have to be equal if AB and AC are equal? B and C have to be equal to each other. So if A is 58, and we know the total angles is 180, take away the 58, it gives you 122 degrees left over. Split it equally between B and C. How big is angle C? 61 degrees. Sound a lot like a problem that we did multiple times in geometry last year? There we go. Questions?
I thought angle C and angle A was equal.
That's what I thought.
Right, so that's why if you look at my paper, I don't know that you can see this very well, but I marked AB and AC equal, like it said right here. I went and marked them, and then I also marked them, that means opposite angle B and opposite angle C equal. That way I didn't fall into the trap of just being like, oh, I guess C and A must be equal, because I could have been, right? I wasn't sure. So marked it with the little markings we learned in geometry to make sure I got it right. Number 26. Yeah. All right. 1.488 square kilometers of Earth's surface is land. Everything else is water. which is 3.63 E8 square kilometers. If a returning space capsule lands at a random point, what's the best estimate of probability that the space capsule lands in water? All right, to find probability, we need to take everything we want over everything we got, right? We want water, right? So how much of it is water?
3.63
3.63 E8 is water. Okay, how much of it is, well, what's all we got? Total. What do we have to do? Add them together to get what? 5.11 E8, right? So we want water, total desired outcomes over total possible outcomes. Knock off the E8s and just divide 3.63 by 5.11. What we got? 0.710. In other words, roughly 71% chance it hits water if it goes at random. Now, if I'm in the space capsule, and frankly, there's not a whole lot of land you can hit without damaging something important. Now, Wyoming, there's plenty of space out there. You might hit a buffalo or something.
There's plenty of space.
But anywhere else on the planet, you're pretty, Sahara Desert maybe, right? But most land has stuff there that people want. So it's a good thing to land in water, so maybe we shouldn't just take our chance and be like, well, we'll see what happens, boys. Or girls. I mean, we don't want to discriminate against our female astronauts.
Adios.
We also don't want them to die.
basic
But
was-
anyway. All right, number 27. On the first 7 statistics tests of the semester, Jamal scored 61. That's not good. 76. Oh, they ranked him for you. Okay. So he didn't necessarily score a 61 on his first test. 61, 76, 79, 80, 80, 84, and 91. Okay, so that's pretty diverse. He had some really good tests and a couple, one really bad test, but yeah, that's pretty rough. I would say the 61 is an outlier, by the way, because it's 15 points off his next lowest. The 91 is only 7 points off the next highest, so 61 much more of an outlier here. It says the mean, median, and mode of his scores were 79, 80, and 80, respectively. Then on the 8th statistic test, Jamal scored a 90. How do the mean, median, and mode of his 8 scores compare to the mean, median, mode of his first 7 scores? Now, you could recalculate that, but that's a pain. What's going to happen to the mean if he gets a 90? Well, what was his mean originally, according to the problem? 79. Would a 90 make his mean higher or lower? Higher. So we expect the mean to get greater. So that means we can rule out letter A. All right? Is a 90 going to change the mode at all? No, because the mode is still going to be 80. So that rules out options B and D now. We're now down to either C or E. Because we need the mean to get bigger, we need the mode to be equal. So the question is, what's going to happen to the median? Well, if you stick the 90 there, again, let me list out the numbers again as they are on the paper, because this is what I would do on the actual test copy. I would sneak my 90 right there, and I'd redo the salt and pepper. Salt, pepper, salt, pepper, salt, pepper, salt, pepper. Well, what's the median going to be now? Still 80.
Yeah.
So the median stays equal. That makes it option E. Do you see how to think through number 27? You know a 90 is going to bump the, it's like your grades, right? You know a 90 is going to bump a 79 grade up higher.
Yep.
You know that it's not going to change the mode because it's not like you got an 84 and now there's 2 modes or something. Okay? It's just what does it do to the median? Drop it in place. Recheck your median real quick. Stays the same. Letter E. Questions?
So I know the first two things, but mode, I can't quite remember.
Mode is the number that occurs the most often.
Oh, okay.
So since there were 2 80s and there weren't doubles of anything else, 80 is the mode. Yep. All right, number 28. Solid rectangular prism shown below is built by alternating congruent black cubes and white cubes, such that 2 cubes of the same color have at most 1 edge touching. What's the total number of white cubes used to build the prism? All right, basically what they're saying with the 1 edge touching thing, that's just saying it really looks like what it looks like here, okay? So don't get weirded out by it. So what I did was, I looked at this and I'm like counting over 1, 2, 3, 4, 5, 6, 7 cubes across the bottom. And I counted up 1, already there, 2, 3, 4, 5, 6 cubes high. And then I counted across the top. I'm like, okay, that front corner cube, black, white, black, white, black. That's 5 more cubes. And so I just found the volume, length times width times height. And I found the volume to be 210 cubes. Now, how many of them are going to be white? Well, they're black and white. And it's the same number, right? Half of them are going to be black, half of them are going to be white. So what's the answer? H, 105, half of them. Does that make sense? So just count 7 by 6 by 5, or whatever order you want to do length, width, height, it's up to you. Find how many cubes there are total, and you take half of them, because half of them are black, half of them are white. Questions on that? One more. Number 29. We're almost halfway through. One-sided square ABCD has a length of 12 meters. A certain rectangle, whose area is equal to the area of ABCD, has a width of 8 meters. What is the length in meters of the rectangle? This is like exactly something we did in geometry. We have a square that's equal to a rectangle. What's the formula for the area of a square?
4S.
Side square, that's perimeter 4S. What's the area of a rectangle?
L space.
Length times width or base times height. We'll go with length times width because that's the terms they use. If the side of the square is 12, 12 squared gives us 144. And it says if the width is 8, what's the length? Class? C, 18, when you divide 144 by 8. So literally exactly like something we did multiple times, in fact, in geometry last year. One more. That way we can say we made it exactly halfway through. Number 30. The average of a list of 4 numbers is 92. A new list of 4 numbers has the same first 3 numbers, but the 4th number in the original list is 40, and the 4th number in the new list is 48. What's the average of this new list of numbers? Okay, so here we go. We got numbers, and they give us a total, which we don't know, and we divide that total by 4, we get 92. Y'all got it? We have a new list of numbers. They have the same first 3 numbers, but now they have a 48. So they don't get this sum. What's going to be true of the new sum?
Plus 8.
It's going to be sum plus 8, right? It's going to be 8 bigger. So if I take 8 bigger and divide it by 4, what's going to be true of my answer? It's going to be 2 bigger, right? Because the 8 is divided by the 4, so it's going to be 92 plus 2. So what's the average going to be? 94. You get 8 bigger, you get 2 bigger on the average, 94. And there's our answer. How many had H? 94. All right, so the good news, Chris, if you go back and reprint, you can do the first 30, check by video, your answers, and if you do the last 30 like you should over the weekend, then we'll be able to go over those live in class, and you'll be able to be a part of this. All right. No homework other than finish your ACT practice test if you didn't already. Chris, have a wonderful rest of your day and a good weekend. Go Crusaders. I won't say go Sharks because then I can be accused of impartiality.